Hello ladies and gentlemen, this is Mr. Cunningham, and what you are going to be doing today is we're going to be going over notes 12.4, which is over the ideal gas law and stoichiometry. So before we get started on that notes page, what I'd like you guys to do is go ahead and take a few minutes and answer that bell work question. Again, this is just some review of some previous lessons, so take a minute and go ahead and complete that. Alright, now that you're done, what we're going to talk about first is, again, going over our objectives and our goals for this lesson. So sub-objective 1, which, again, you should be following along on the 12.4 notes page. Sub-objective 1 says you need to be able to balance a chemical equation. Okay, that's something we've been doing for months now. You need to be able to do that, is balance a chemical equation. Otherwise, you won't be able to do the types of problems we will be working on in this lesson. Sub-objective 2 says you need to plug in the correct values into the ideal gas law. We'll be using the ideal gas law today. So that was what our last lesson was over. If you need to go back and review that, you can. Then our goal is to be able to solve for an unknown amount of gas using the ideal gas law and stoichiometry. Yes, we are still going to be doing stoichiometry just like you've been doing in previous units. So let's go ahead and get started. So this is our goal. This is the thing that we are trying to accomplish. Okay, the goal on our paper, which says be able to solve for an unknown amount of gas using the ideal gas law and stoichiometry, is what you're going to have to do in this problem. So here's what it says. It says consider the combustion of propane gas. And here is the equation for the combustion of propane gas. This is propane gas. All combustion reactions react with oxygen. So it's propane reacting with oxygen, and again, the products of every combustion reaction are CO2 and H2O. So here's what it asks us to do with this problem. It says, what volume of oxygen gas at 25 degrees Celsius and 1.04 atmospheres is required for the complete combustion of 5.53 grams of propane? Okay, that's the question we're going to try to answer today. So I know that you guys, I've been saying the word stoichiometry, I guess 2 or 3 times so far in this lesson. We are going to be doing stoichiometry again. Again, anytime you can find moles of something, specifically of a gas, then yes, you can do stoichiometry. Okay? So what we're going to be doing today is, in this lesson, you'll be doing really one of a few things. You'll be able to use this equation, again, called the ideal gas law, PV equals nRT. You'll be able to use that to find moles before you do stoichiometry, or you might use that to find pressure, volume, or temperature after stoichiometry. So in order to kind of start doing some stoichiometry, what I want to do first is I want to review the steps of stoichiometry. Again, the first thing that you do before you can ever do stoichiometry is you have to have a balanced chemical equation. Again, emphasis on the balanced. We're given in the problem that is our goal for today, we were given a chemical equation, but it's not balanced yet. Hopefully you noticed that. The next step is you need to find the number of moles of your given substance. Okay, and we're going to label that substance, substance A. Then we need to use the balanced equation to find the ratio of moles of the given substance to the moles of the needed substance. And again, the needed substance we label as substance B. Okay, needed substance we label as B. Then we're going to use our mole map. We're going to convert moles of needed substance to whatever quantity is desired. And again, previously we talked about grams, particles, or liters. We're also going to be talking about pressure and temperature now, because now we're using gases. So here's our equation again. So let's go ahead and give this thing a shot. So the first thing we need to do is we need to balance the equation. So take a minute, look at this equation. I want you guys to try to balance that equation. Then after you answer it, whether it's right or wrong, I'll show you what you need to do in order to balance that equation. So here's how you balance that equation. First thing you need to do, again, the reason we have to balance an equation is we have to have the same number of atoms of each type of element on both sides of our arrow. So over here on the left side, I have 3 carbons, 8 hydrogens, and 2 oxygens, which means I need to try to get those to be the same. All right? So since I have 3 carbons here, that means I need 3 carbons over here. The order of balancing a combustion reaction is balance the carbons first, then balance the hydrogens, then balance the oxygens. So I have 3 carbons over here, which means I'm going to need 3 carbons over here. The only compound on this side that has carbons is this one. So I need 3 carbons. And again, I'm going to add a coefficient of 3. That means multiply this compound by 3. Meaning I will need 3 CO2 molecules so that I get 3 carbons. So now my carbons are balanced. Next thing I'm going to balance is my hydrogens. So over here I have 8 hydrogens on the left side of this equation. On the right side I only have 2. So I need to get this side from 2 up to 8. So I'm going to put a 4 right here. Then the last thing I do is I balance the oxygens. So I have 2 oxygens on this side, and I have 3 times 2 here, which gives me 6, plus 4 times 1. So 3 times 2 is 6, 4 times 1 is 4, so 6 plus 4 gives me 10. I have 10 oxygens on this side, which means I need to get 10 oxygens over here. So because I have a 2 here, that means in order to get 10 oxygens, I'm going to need 5 of those molecules. Now my equation is balanced. So now that I have a balanced equation, now I can actually start doing stoichiometry. So we're going to switch to the next page, and we're going to actually start doing our problem. So remember our mole map, okay? In our mole map, basically what we have had this. We've had you can convert from grams of A to moles of A. We've had you can convert from particles of A to moles of A. We have you can convert from volume of a given substance at STP, to moles of A. The thing we are now adding is this. If you are given pressure, volume, and temperature, you can find moles using PV equals nRT. Here's why. If I know my pressure, if I know my volume, if I know my temperature, remember R is a constant. It's always 0.0821. So if I know those 4 variables, then I can solve for my 5th variable, which would be N. N stands for moles. So if I know pressure, volume, and temperature, I always know my R value, which means I can solve for moles, which means I can convert to moles. Okay? Then we'll just use our B over A conversion, which is our stoichiometry stuff from our balanced equation. Then, if I'm in moles of B, I can do all of these things to convert to something else. So if the problem asked you to find pressure, volume, or temperature, well then once you have moles, you're going to use PV equals nRT. You'll use the moles that you got here, plug it in to PV equals nRT. It would have to give you 2 of these 3 values. So if it said something like, what is the temperature at which this reaction occurs? It's going to have to give you pressure and volume. So if you have pressure, volume, moles, again you always have R, that means you can find temperature. Okay, then obviously you can also convert using these other methods, which are things we've already done prior. Okay, so let's go ahead, let's try this problem, let's walk through it. So here's our question. It says what volume of oxygen gas at 25 degrees Celsius and 1.04 atmospheres is required for the complete combustion of 5.53 grams of propane. So let's plug in our balanced equation here and let's solve this. So I'm going to start by highlighting some things that would be important. So first of all, it says what volume of oxygen? So what volume of oxygen gas? That's what it asked us about. So that means oxygen is my substance B, because it asked me to find information about oxygen. And it says it's at 25 degrees Celsius and 1.04 atmospheres is required for the complete combustion of 5.53 grams of propane. So I'm given information about propane. I have 5.53 grams of it. Okay? Now, you might say, well, wait a minute, I'm given a temperature and a pressure. Well, let's go back to that mole map real quick. I can only convert to moles if I'm given pressure, volume, and temperature. If you go here, I'm only given temperature and pressure, not volume, which means I can't use just temperature and pressure to convert to moles. But I can use grams, okay? So since I'm given grams, this 5.53 grams of propane, that's going to be my substance A. Propane is my substance A. This is the formula for propane, making it substance A. So now I am ready to actually start planning what I'm going to do using my mole map. So again, I'm going to backtrack a little bit so that we can walk through this. So right now, I know how many grams of propane I have. I had 5.53 grams of propane. So here's what I'm doing. I'm starting here. I'm starting in grams of A. I'm going to use the molar mass of propane to get to moles of A. Then I'm going to use my balanced equation to find my B over A conversion, and I'm going to multiply that. Once I get here, I will be in moles of B. Then, what did the question ask me for? It asked me, what volume of oxygen gas? So, you might say, oh, well, we've been able to find volume this way. Well, we actually cannot use this conversion anymore. Here's why. This conversion, the 22.4 liters, can only be used to find volume at STP. STP stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius, or 273 Kelvin, and 1 atmosphere. And we are not at those conditions anymore. Once we've started using gases or talking about gas laws, sometimes our conditions change. Well, our conditions are not at those precise, or at STP, those precise conditions, so we can't use this anymore. But we can use the ideal gas law. So what we're going to do is this. Start from grams of A, convert to moles of A using the molar mass. Then we're going to change from moles of B, or excuse me, to moles of B using the B over A conversion. Then we're going to find our temperature, remember that's what the, or excuse me, find our volume using this conversion by using PV equals nRT. So now let's actually run through and do that problem. So I've got 5.53 grams of propane. And I'm going to convert that to moles. Again, how I convert that to moles is I need to divide by the molar mass of propane. So I'm going to set this up using dimensional analysis. So I have 1 mole of propane on top. And I need to find the molar mass of propane. Well, it's got 3 carbons. So that's 12.01 times 3, which would be 36.03. And I'm adding that to 8 hydrogens, which would be 8.08. And that gives me 44.11 grams, which means 1 mole of propane would weigh 44.11 grams. So I'm putting that on the bottom. That's my first step. Using this conversion, I would be converting from from grams of propane to moles of propane. Now, the next step, again, using that chart, is to convert from moles of A to moles of B. So to convert from moles of A to moles of B, I need the B over A conversion. Well, here's substance B, it's oxygen. We labeled that initially in our problem. Its subscript, or excuse me, not subscript, its coefficient is 5. So, because it's B over A, I have 5 moles of O2 for every 1 mole of C3H8. And I'm going to stop right here for now. And you might say, well, wait a minute, we're not done. Well, we're done using dimensional analysis. Because the next step, the next thing we need to do, if I stop right here, I am now in moles of B. And the next thing on our mole map that we need to do that we talked about earlier is now I need to convert from moles of B, or moles of oxygen, to my desired amount using PV equals nRT. So I'm going to go ahead and do the math here to figure out how many moles of oxygen I would need. So I take my 5.53, divide by 44.11, and then multiply by 5. This is how many moles of oxygen I would need to react with 5.5 grams of propane. And it would be 0.627 moles. So this number I am now going to use. Okay, because now I'm going to use PV equals nRT. And you might say, okay, so this is my mole amount. I have this many moles of oxygen. It's going to go in right there for N. I know that this reaction is occurring at 1.04 atmospheres. So that means this number here is going to go in right there. And this temperature is going to go in right here. However, I cannot use, remember whenever I'm working with gases, I cannot leave my temperature in Celsius. I have to change it to Kelvin. So we're going to have to do that first. So my pressure is 1.04 atmospheres. So I've got 1.04 times V. Now again, you might be like, well, it asked us to find volume. That's what I'm going to be solving for is V. I'm going to plug in my 0.627 for my moles of oxygen. I'm going to plug in R. Remember, R is 0.0821. Remember, there's multiple different values of R that we could use, but so that I only have to use one R value, 0.0821, my pressure has to be in atmospheres, my volume will be in liters, my temperature has to be in Kelvin. So that's what, now I need to plug in this temperature, but it can't be 25. I have to add 273, which is going to be 298. And now I solve this equation, and I'm solving it for volume. Because the question asked me what volume of oxygen. So I'm going to solve this side first. So I have 0.627 times 0.0821 times 298. And this side gives me 15.34. So I have 1.04 times V is equal to 15.34. So now I divide both sides by 1.04. And I get 14.75. And again, this is volume, and because I used my R value here, this has to be in liters. And that would be the answer to my question. Okay, because it said what volume of oxygen gas at these certain conditions, I used those certain conditions, so this would be the volume of oxygen that I would need. Okay? Let's go ahead, let's give another one a try. So here's what this one says. It says when calcium carbonate is heated, carbon dioxide gas is evolved. Evolved means given off. How many grams of calcium carbonate are required to produce 3.45 liters of CO2 gas at 29 degrees Celsius and 1.25 atmospheres? So, let's identify, again, first thing we have to do is, in stoichiometry, number one, balance the equation. So let's check and see if it's balanced. See, I've got one calcium here, one calcium here, one carbon here, one carbon there, three oxygens here, one oxygen here, and these two oxygens. This equation is balanced. The coefficients are all 1. Now let's identify our given substance and our desired substance. So it says how many grams of calcium carbonate are required. There's our question. So we're looking for how many grams of calcium carbonate. So we need to find calcium carbonate. Well, this is calcium oxide. This is carbon dioxide. This has calcium in it. This is the formula for the polyatomic ion carbonate. So that means this is calcium carbonate. This is substance B. And it says are required to produce 3.45 liters of CO2 gas at 29 degrees Celsius and 1.25 atmospheres. So, we are given a volume, we are given a temperature, we are given a pressure. I'm going to backtrack a little bit to look at our mole map. So, here, we have to start in one of these values. Notice how here it says pressure, volume, and temperature given. In the previous problem, we were not given pressure, volume, and temperature. We were only given pressure and temperature, no volume. But in this question, we are given volume of CO2, we're given the temperature of that CO2, and we're given the pressure of that CO2, which means pressure, volume, and temperature are given. Which means in this case, here's what we're going to do. We are going to use PV equals nRT first to get to moles of A. Again, the reason we can do that is because pressure, volume, and temperature are given. So I'm going to use those variables to get to moles of my CO2. Then I'm going to take my moles of A and convert to moles of B using my mole ratio. Then the last thing is, it asked us to find what? It asked us to find grams of calcium carbonate. So then I'm just going to convert from moles of B to grams of B using the molar mass of calcium carbonate. Okay? So let's go ahead and let's do that. So again, it asks us to find grams of calcium carbonate. So that was B, which means since I was given pressure, volume, and temperature of CO2, that means my CO2 is A. So I'm going to use PV equals nRT first, and I'm going to plug in these values. Again, in order to use the value of R, that's 0.0821, I have to make sure my pressure is in atmospheres, my volume is in liters, and my temperature is in Kelvin. My pressure and volume are good, but my temperature is not in Kelvin. I'll have to change that. So my pressure is 1.5, so I'm going to have 1.25. 1.25 times 3.45 equals I don't know that, that's what I'm solving for, times R, again, R is always the same number, 0.0821, times T, which is my temperature, but I can't use 29. I have to do 29 plus 273, which is going to be 302. Now I solve for N. So I'm going to solve both sides here. So I'm going to do 1.25 times 3.45, excuse me. And that's 4.31. I'm going to do 0.0821 times 302, which is 24.79. And now I'm going to divide both sides by 24.79. And I get that my N, or my moles of CO2, would be equal to 0.174. So this is my moles of CO2. I have now found moles of A. In other words, I have just done that first conversion. I've converted my pressure, volume, and temperature of CO2 to moles of CO2. Now I'm going to continue using dimensional analysis, and this will be my starting value. Okay? So let me erase this real quick, and we'll continue that. So I've got my 0.174 moles of CO2. My next step is I need to multiply by B over A, because again, what we just did was this conversion step here. We converted from pressure, volume, and temperature to moles. Now we're converting from moles of A to moles of B. So my coefficient, I have 1 mole of B for every 1 mole of A. So that means I'm just going to multiply by 1 mole of CaCO3 for every 1 mole of CO2. Again, that's 1 over 1, which means, really I'm going to multiply by 1 and then divide by 1, which does nothing. The last step is, again, it asked me to find how many grams of calcium carbonate. So, to change from moles of calcium carbonate to grams of calcium carbonate, I'm going to multiply by its molar mass. So to find the molar mass of calcium carbonate, calcium's molar mass is 40.08. Carbon is 12.01. Then I need to find the mass of 3 oxygens, which is 48. And I get 100.09. So that means I'm going to multiply by 100.09 grams for every 1 mole of calcium carbonate. Again, my moles of CO2 are going to cancel there and there. My moles of calcium carbonate are going to cancel there and there. So I'm going to do 0.174 times 1 divided by 1, which does nothing, and then times 100.09. And I get that I would have 17.41 grams, and that would be of CaCO3. So in other words, I would need, if I wanted to produce 3.45 liters of CO2 at this temperature and this pressure, I would need to start with 17.41 grams of calcium carbonate. This is my final answer. Okay? So, things to review real quick. Remember that shortcut that we have been using. Here's why that shortcut works. Okay, remember when in previous units we could convert directly from volume to moles by using that 22.4 liters conversion? Here's why that works. If you use standard temperature and pressure, which means if you use a pressure of 1 atmosphere, a temperature of 273 Kelvin, you actually, if you plug that into PV equals nRT, you actually get 22.4. So a mole of gas at 1 atmosphere of pressure and 273 Kelvin occupies 22.4 liters. That's how we get that volume. That's how we get that 22.4. So, if you can convert from moles directly to liters, or you can convert from moles directly to liters, if and only if the pressure is 1 atmosphere. So in other words, what I'm saying is you can only use that quick and easy conversion from moles to volume if your pressure is equivalent to 1 atmosphere, your temperature is 273 Kelvin, and the substance is a gas. Okay, the substance has got to be a gas in order to use that conversion. If your conditions aren't that, so these previous 2 problems we did, guess what? Our temperature, our pressure was not at these values. Well, that's okay. We can still work around it. It's not as easy, but if our conditions aren't at standard conditions, which are these, then you have to use PV equals nRT to convert to moles. And that's not, it just takes a little bit longer. So again, here's our mole roadmap. You're going to use this. Really all we've done is we've updated it and put these 2 extra things on it. Nothing else is going to change. Okay, so here's what I want you guys to do now. I want you to go ahead and try this problem. You'll have some problems that you'll be able to do on this video. You can try those. It'll give you the answers. Make sure if you have any questions that you ask me. But as far as that goes, that's all for our video for today. Thank you for watching.